Aim: to find the spring constant of a helical spring by method of oscillations of a known load and check the result by measuring its extension by a known force. Apparatus: spring, clamp stand, slotted weights, meter scale and stopwatch. Suspend the helical spring from a rigid support and adjust the scale such that the zero of the scale coincides with the pointer of the spring. Now, we suspend 50 grams of weight at the lower end of the spring. Wait until the pointer comes to rest and note down its readings. Here, it is 8 centimeters. Note it down in the observation table. Now, pull the slotted weight a bit downwards and leave. The weight begins to move up and down and oscillates vertically. Here, we need to measure the time taken for 20 oscillations. Therefore, the time taken for 20 oscillations is 12 seconds. Note it down as T1 in the observation table. Now, once again, measure the time taken for 20 oscillations. Therefore, the time taken for 20 oscillations, it is 13 seconds. Note it down as T2 in the observation table. Now, we take the mean of T1 and T2 as the time for 20 oscillations. Therefore, T is equal to 12 plus 13 by 2, which is 12.5 seconds. For more observations, repeat the procedure by increasing the weights to 100, 150 and 200 grams. And in each case, we calculate the time period T and square of the time period. For a load of 50 grams, the position of the pointer is 8 centimeters and the time taken for 20 oscillations T1 is 12 seconds and T2 is 13 seconds. Therefore, the mean time period T is 12.5 seconds and the corresponding time period square is 156.25. Similarly, the values for the load of 100, 150 and 200 grams are. Now, we plot a graph between mass suspended m and time period square T square. Consider mass m on x-axis and time period square, which is T square, on y-axis. The scale on x-axis is 1 centimeter is equal to 50 grams and on y-axis 1 centimeter is equal to 80 seconds square. M2 minus M1 is equal to 200 minus 50 which is 150 grams. T2 square minus T1 square is equal to 400 minus 156.25, which is 243.75. From the time period formula, force constant K is equal to 4 pi square into m2 minus m1 by T2 square minus T1 square, which is 4 into 9.8696 into 150 divided by 243.75. Therefore, force constant K of the given helical spring is equal to 24.29 gram weight per centimeter. Precautions. The spring should be suspended freely from a rigid stand. Loading and unloading of the weight must be done gently. Reading should be noted only when the tip of the pointer comes to rest. Pointer tip should not touch the scale surface. Loading should not be beyond the elastic limit.